All right, so this video is going to be the longest. And again, at any time during the video, you can pause it and start working on the homework problems. And you can always come back if you see some harder problems that you want to look at. Okay, so we're going to just review some properties of rational exponents and then do some simplification problems. But you already have all of the tools in theory to do this video's homework problems. All right, so this should be a review. We talked about most of this on Friday when we did 8.2 stuff. But if I have two things with the same base, we can just combine them by adding the exponents together. Similarly, right? If we have the division of two things with the same base, we can just subtract those exponents. We have an exponent with an exponent outside. We'll multiply them. And a negative exponent means reciprocal. And it becomes positive. We can rewrite this other one, right? Sometimes as 1 divided by x to the negative n. It's just going to be x to the positive n divided by 1. Don't need to always write that down. And then the last one is if I have two things multiplied by each other that both get an exponent, each one gets the exponent as long as there's no addition. So again, this should be somewhat review from what we talked about on Friday, but feel free to pause the video right now and write these down so you have them all together. These 5 properties are going to be very useful here. So go ahead and take a moment to get those down. And then again, be very careful with this last property as well, is it does work backwards as well. We can only combine things if they have the same exponent, like so, or the same base, what's on the bottom of the exponent, like so. All right, so either need the same top or the same bottom. So let's get kicking with some examples. Watch out for negatives, watch out for parentheses, strap yourselves in, because this might knock your socks off. But if you strap yourself in, I really don't know how that secures your socks. So here we go, simplify. And here we're going to do something really nice. Y'all are going to love this. Assume all variables are positive. So we do not have to worry about absolute values anymore. Well, in 8.2 you will. So on your quiz, you will have to for half of it. But sometimes we won't be worrying about it anymore. Part A, 125 to the 2/3. And part B is going to be similar, 16 to the negative 3/2. Be very careful about those negative exponents. All right. So this first one, we're just going to convert it. And remember that there's 2 ways to convert it. So don't write this down. But we can either write this as the cubed root of 125 squared, or the cubed root of 125 squared at the end. Now, they're both right. But one of these is a lot easier than the other. Because I, for one, if I follow order of operations, I don't want to deal with this. I don't want to square 125. That's a big number. And I certainly don't want to have to take the cubed root of it afterwards. So be a little careful. Sometimes one form is going to be better than the other. So that second form is really going to be what we like here. We're going to write this as the cubed root of 125. And then we'll square whatever we get afterwards. Remember, numerator is the exponent, and denominator of our rational exponent is our index. So, cubed root of 125, that is 5. And we still have to square it to get 25. And again, you should be able to type this in your calculator and get the right answer as well. I'd recommend you do it both by hand and with a calculator, because when you may have variables, that process will still be important. For B, though, first we want to deal with that negative exponent. So negative exponent means reciprocal. So we almost write down the same thing, but now it's in the denominator, and now the exponent's positive. And just like last time, it's going to be 1 divided by the denominator of 2, means square root, and we can either write that exponent of 3 right here, or right here. And again, I think the second one's a little easier. We're not really going to have room for this. Square root of 16 is 4. 4 cubed is going to be 64. We get 1/64th as our final answer here. This stuff too, what we're doing right here, is going to be very important in 1400 when we start talking about logarithms. Everyone loves logarithms. That's why love and logarithm start with the same letter. Has nothing to do with the Greek word logos. It all has to do with what letter it starts with. All right, part C. Let's do some more of these. And again, this video really is just a bunch of examples that get harder and harder to give you something to look at when you're looking at the homework problems, give you something to model, give you a little bit more experience with these problems. So again, don't confuse where the negative is and where the parentheses are right here. The negative exponent on C means we initially start by putting reciprocal. 32, now it becomes to the positive 2/5. Negative exponent, reciprocal. Now we convert it. The denominator of our exponent becomes our radical index. That's supposed to be a 5. And then the 32 goes here. Again, we can either put the exponent right there, or what's usually a little easier, on the outside. The 5th root of 32 is just 2. The exponent of 2 on the outside is still there. We're going to get 1/4 as our final answer for C. Anytime you have a negative exponent, your answer should be 1 over something, unless there's some other number. Then it might be that other number over 4, for example. Careful with D. The negative, there are no parentheses here. So the negative is outside. The negative is not participating. The negative does not go inside the radical. Only the 25, because there's no parentheses. All right. The denominator becomes our index, so it's a square root. And that numerator is our exponent. It's cubed. So square root of 25 is 5. Then we have to cube that. 5 cubed is 125. And notice for this whole problem, right? This whole problem, the negative doesn't do anything. It's just sitting out in front. We're just copying it down over and over and over again. Because it's not in parentheses, it's not getting the exponent. So it's not getting the radical either. And that'll be our final answer here. Okay, so for all of these, it's just really so many things that you can get wrong here. And so many small mistakes, even though I think at its core, I think this section is going to make a lot of sense for a lot of people. It's just kind of putting it all together. That is where the trickiness comes into play. All right, let's do some more. Negative 25 to the 3/2. Again, I'm really wanting to iron out these negatives right here. And then x to the 1/2 times x to the 5/6. I love that word, sixths. Lots of consonants in there. Very hissy. So E, as opposed to D, right? One has parentheses and one does not. So the parentheses means everything goes under the radical, negative 25. The numerator of that radical is still 3, and we're done. We're done with letter E. Hooray. Because we have the square root of a negative number, this isn't real. And we haven't talked about complex numbers yet. We're just going to go ahead and say right now, this is not real. In 8.8, there's a lot of fun things we can do with this problem. But for now, enjoy your little freedom. Sit back in your rocking chair and enjoy the breeze. It's a very sunny, nice, beautiful day here on Sunday. All right. So that's all we're doing for this one. In part F, notice that both of these have the same base. The bottoms of these exponential functions, expressions, are both x's. So we can just add the numerators. We'll have x raised to the 1/2 plus 5/6 again. And again, your calculator can help you with 1/2 plus 5/6, or you can get a common denominator. 1/2, that's the same as 3/6. Multiply the top and the bottom by 3. So 3 over 6 plus 5 over 6 is 8 over 6. Sorry, I was adding extra consonants to that word. And then we just reduce. Always remember to reduce your fractions if possible. 8 over 6 is the same as 4 over 3. Fun fact. So turn off your ears, by the way, if you don't want to be confused. Turn off your ears. Or it is a video. Turn off the sound. These last two things are only equal when we're assuming that x is positive. If x is negative, they're not actually the same thing. That's why we're assuming everything's positive here so that we actually can reduce. Because this top one requires absolute values, but this bottom one does not require absolute values. So those are different things depending on whether things are positive or not. But anyway, that's not really that important for this section, but it's just a little fun math fact, a little bonus fact. All right, you're paying for this class, or someone's paying for this class. That's a little bonus, a little extra. You don't even have to tip the college for that one. All right, let's keep going. We're just going to get messier and messier problems. Z to the 9th raised to the 2/3, and part H as in hippopotamus, x to the 1/3 divided by x to the 5/3. So both of these, we're just going to use our properties, okay? This first one, we multiply these exponents. We'll have z to the 9 times 2/3. Well, what is 2/3 of 9? 2/3 of 9 is 6. You can also write 9 is 9 over 1 and have 18 over 3, which is also 6. Well, I'll just have z to the 6th power right here. Whereas in H, multiplication means add the exponents. Division means subtract the exponents. This becomes x to the 1/3 minus 5/3. They already have the same denominator. That's neat. And we'll get x to the negative 4/3. And then what we'll get is 1 over x to the positive 4/3. Remember what negative exponents do. And I'm okay with this as a final answer for this section, probably. I don't remember if the book simplifies this more. But remember 4/3? That's 1 1/3. You could also follow some steps to get x divided by, or x times the cubed root of x right here. I'll take either one here for this section. If I want you to simplify the thing on the left, I'll put it in 8.2 probably. Let's do some more. Part I, as in the square root of -1, imaginary numbers. Part J, as in the square root of -1 for imaginary numbers. Fun fact, a lot of applications will actually use J as the square root of -1. Right? Like I believe physics and engineering like to use J a lot, if I'm not mistaken. All right, 3 more problems. Just going to make them a little bit more complicated. 27 u to the 1/2 raised to the 2/3. Now again, be very careful. That 2/3 is going to both of these. The 1/2 is only going to the u. 27 is not getting the 1/2. So what we're going to do is we're going to start by giving this 2/3 to both things. We're going to have 27 to the 2/3. We'll deal with that. Times u to the 1/2 to the 2/3. So both of these things are getting an exponent of 2/3. Notice how I wrote down j, but I didn't actually give you a problem over there. Don't worry, it's coming. All right, so 2/3. The denominator of that exponent becomes the index of the radical. The numerator becomes an exponent. And you can either put the exponent outside or inside. We'll put it outside. It's a little easier. For the second thing, we multiply those exponents together. So we're going to have 1/2 times 2/3. And we get some nice cancellation here, right? 2 on the top, 2 on the bottom, cancel each other out. Real nice. Cubed root of 27 is 3. There's still that exponent of 2. U to the, well, we're just left with the 1/3. Great. 3 squared is 9. And you can either write that as u to the 1/3 or the cubed root of u. Up to you. Again, if you wanted to write it like that, that's also okay. Sometimes the exponent is nicer. Sometimes the radical is nicer. One's not simpler than the other. You just should be able to switch between them. All right, so I will take either form. 2 more problems. Let's get going. Actually, yeah, we already did that last problem. 1 more problem. Part J. It's going to be on the next page because it's a big one. Part J is, all right, get your biggest parentheses you've ever drawn in your life. Maybe not that big. 16 x to the 4/3 y to the negative 5/6 divided by x to the negative 2/3 y to the positive 1/6. And if that is not enough, all of that is raised to the 1/2 power. So lots of stuff going on here, but don't worry. Just treat things one at a time. We're going to simplify the inside first. There's a lot of orders on which you can do things. But notice we do get simplification on the inside if we look at these things. They're being divided, you can subtract their exponents. 4/3 minus a negative 2/3, which is just 4/3 plus 2/3. But that step can be a little overwhelming to do it all at once. So I like to just move the negatives. Deal with those negative exponents first. Let's put this negative exponent up top. Let's put this guy with a negative exponent down bottom. All right. We're going to have 16. Still have the x to the 4/3 from before. Now that x to the negative 2/3 comes to the top as a x to the positive 2/3. The y to the negative 5/6 goes to the bottom as y to the positive 5/6. And again, there's still the y to the positive 1/6 as before. And just like I mentioned in 8.2 on Monday, be very careful that your parentheses are big enough. This parentheses should cover the whole thing. All right, now we can simplify that inside. X to the 4/3 plus 2/3 is 6/3. 6/3 is 2. All right, just going to go off to the side. Okay, 4/3 plus 2/3. That equals 6/3, which equals 2. So that's where that 2 comes from. Again, a lot of times, especially for these messier problems, it's a-okay to go off to the side and just simplify off to the side so you don't have to write quite as much. We'll do the same thing for the bottom. 5/6 plus 1/6 is 6/6, which is just 1. Already much nicer. Now, all of this stuff is underneath the square root. On the next page, we'll write the square root of this inside, because all of it has an exponent of 1/2. So the square root of 16 x squared y. Is there really just a y on the bottom? I'm surprised the book asked this. Anyway, so square root of 16, that's 4. The square root of x squared is the absolute value of x. We're assuming everything's positive in this section, so we are not writing absolute values in this entire section. And the bottom is the square root of y, which in future sections we'll talk about how to rationalize this denominator, but for today, we will leave it like so. So again, it's a long video, but I just wanted to give you a lot of example problems. So as you're working on the homework, hopefully the homework problems are going to look like all of these problems. So you look at a homework problem and say, oh, maybe I don't know how to do that. Or, oh, maybe the book got a different answer than I did. Try to find the corresponding problem here, and then look back on it. So I purposely made this video long to give you guys a lot more examples than I gave you last time. And I'm hoping that it's helpful. Anyway, good luck, and please don't hesitate to ask me questions on the homework. Bye-bye.